Welcome back. This is going to be the part 2 video. Go a little bit deeper into rendering, animating textures, materials, colors, lights, shifting those properties over time with animation keys. And if this is the first video you're seeing, please notice that there was a previous one you should watch before on materials, colors, and textures. We're going to start just by going into one problem to be solved, and that had to do with transparencies. And then we're going to go into something more exciting than just a polygonal sphere. And for those in experimental animation that's using the entity that's deforming the surface, all this is really going to come to life. Some very fun and kinds of fantastical results will just start to emerge. And last we left off, we did some animation keys with colors, animating the textures, transparency maps, bump maps. We learned about changing those keys over time and even moving and animating colors of lights just on these simple spheres. And that looks pretty cool. We have even a bump map here that had elephant skin on it, and over time as they move they show shifting and swirling experimental animation kinds of looks. But we also got into rendering, and I mentioned we're only seeing things through the graphics card. Right here we're looking through the viewport. This is just the renderer, let's just call it the perspective view scene that only displays off the graphics card, and it's not a sophisticated renderer that takes into account the light interaction and all the physics and properties. So we looked at the Arnold renderer, as I mentioned. That's the most sophisticated one we have. And if I went up to the Arnold render view, and I showed you it was up here, and it opens the Arnold render view, and this one's interactive, the Arnold render view I mentioned before, and it has this red arrow, and I click it, and the problem there was it wasn't showing the transparencies well. It is a true render, so it's showing shadows, and we have reflections, different kinds of absorptions and rejections of light. The specular looks different. Overall, it's a slicker improvement, except it's not doing any of the transparencies correctly, almost like it just doesn't exist. However, it's doing the texture well. And it doesn't really do that great of a job on this type of, even the graphics card through the portal view here looks more detailed than what you see in the Arnold render view. So why is that, and why are we recommending that as a render in the first place? I mentioned you could switch to the Maya render and it would have no problem. If you simply went to this eyeball and we did a Maya software render, we would be able to see transparencies, and you could say maybe problem solved there. So this is an older original render, a Maya render, and you can see, yes, using a different render and not using Arnold, you will be able to see then those transparencies, and the some of them look like what you would expect, maybe a more one-to-one relationship to what you're seeing through the portal of the window. Okay, but the Maya software render is much older and not very sophisticated. By far the Arnold render, if we compare it, is the renderer that's going to take into account all kinds of inflected, reflected, absorbed light, refracted light. It considers a much deeper world of light interaction and penetration. It can consider light entering the surface. Arnold will take into account subsurface scattering, translucence, incandescence in a much more realistic and better way. If those are new terms to you, those just have to do with making things look more realistic and palpable, rather than just CGI and plasticky. Let's compare. So let's try to learn that early and aim to use the Arnold renderer. But we're stuck because we want transparencies to render better and bumps to render better. Well, not difficult at all. So I just want to show you really quick how to solve that problem, and then we'll move on to using the entity and putting really neat kinds of textures on there. Anything rendered in Arnold, most things, if not all things, should be used in conjunction with an Arnold material. We talked about those old school materials, which were Lambert, Blinn, Phong, and all that. Well, Arnold doesn't render those really well. They weren't really compiled to interact very well with them. So for things like transparencies and bumps, Arnold material and using Arnold sensitive lights along with Arnold render. So it's more like a package deal. Currently, this one I had put on before was just a Phong E with some of these attributes on it. Well, that won't do for Arnold. So what material should you use? Well, you should use an Arnold material and none of these default ones that we looked before just for practice. Let's do this. I have one sphere inside each other in the viewport. And just pull it off and just keep this smaller one around for reference. In fact, there's a couple of them. I'll just delete one around for reference. I'll put it side by side with the old shader on it, and this one's going to be with the new shader, the Arnold one. All right, so we need to, as you know already, right-click, New Material. We're going to assign a new material, and that pops up, and the old one's up here. We're going to now ignore, and we're going to go to the Arnold, and we have some new ones here. There's a bunch of new ones that they don't really quickly indicate their sheen, but that is really important and comes later. It's what's so essential to grasp that concept first about sheen with simple materials before we move on to Arnold. But here quickly we have new Arnold materials, and the one that's really useful that we could use over and over is just simply called the AI standard surface. It sounds quite boring, but it can do so much more than any of those other materials that you've seen. Again, you go to Arnold, we're putting a new material on it, and we're going to go to AI standard surface. Actually, it usually turns light white gray, but it's pink because of the color of the light right now, so just ignore that anyhow. All right, you could either use the material viewer and the hypershade, or we can just use here, if we go material attributes, and let's just close that. Same data here. I'm just going to use it in the attribute editor. So these Arnold materials usually have this grayish, tiny looking specular on it, but all this boring yet can be changed. So we have this, I'm not going to go into everything, don't worry, but I'll just mention base, specular, transmission, subsurface. There's right here actually something called sheen, which we're talking about specular, geometry, and that has a bump channel in it, emission, so much more physical properties that we can change. You can see dramatic results. We're just going to use 3 of them. Okay, first of all, we're going to match this one, so you can do a side by side. You really are going to understand materials here. So if we're going to look at this one, which is the old material, what was it? It was a Phong E, right? But it had a plastic kind of leather texture on it. We're going to put the same one on this one. This is the Arnold material. It's going to material attributes. Where are we going to put it? We're going to put it on already the base color. I'm going to put it on the base color right here. So click the icon, and we're going to go for a leather, and you recall this part was kind of red, this part was sort of dark brick red or something like that. Sometimes the swatch doesn't update, but it doesn't matter, it's still working here. That's for color. Next one is the bump map. We have this chewed bubblegum kind of bump map on it. How to get that? Well, there's a tab here called geometry. Again, it's on the standard AI standard surface, which is only for Arnold. So this one has a channel called bump mapping, and that's where you put it here. Click the icon, and then we're going to select the noise, which gave it that bumpy look. And let's just leave that default and quick jump to the next one, material attributes, and that's a transparency map, naturally. So we're going to put the checker transparency on here as well. And that would be under a tab called transmission, how light passes through something. It's not called opacity transparency, it's called transmission, same concept. So we're going to go to the weight channel of transmission, and we're going to click the icon, and then we'll put in the checker. There we go. So we're getting the same similar kinds of effects now with an Arnold material. And if we render this with an Arnold renderer, try the render view renderer. Here Arnold's chosen as the renderer, and we're just going to click that button to trigger the render, and we'll see the difference. So there it is. You can see finally Arnold is rendering the transparencies, and you can see the side by side. Anyway, that wasn't difficult. When we take a closer look, analyze our lights, manipulate shaders and colors, we can see how much more sophisticated the render will look. So Arnold is doing all the bumps naturalistically and photographically, and it's calculating a whole lot of internal light bounce that's going on between shiny surfaces, reflective surfaces, diffuse and ambient transmissions of light. It calculates all that light bouncing around in a much more realistic way. Even these areas right here, which are transparent in my window, here in the Arnold render, it's showing the reflective twists and turns of the bump map that's still affecting the transmitted surfaces. Light is passing through something, it doesn't mean it disappears. Light could enter it, and then light could bend and have all these unique new details and features, and even break into kind of, as a prism does, could break the light into different colors. It can think of all that kind of stuff. And we've only used 3 features of the Arnold standard surface. Light participation going on. Anyhow, to animate those textures on an Arnold material is the same strategy that you saw in the other video. It's just going to the materials. You know, we could change the color here, go in the attributes of nuts and base rather. We could change the color here, put keys on one part and change the color to blue. It works just the same as any other material or texture that you're adding color changes to. And if we wanted to change the amount of times it duplicates that checker pattern, remember that checker was in transmission, we could go here and we can change the repeats just the same way. If it repeats 4 times and then later it goes up to 40, I think we had, and then keyframe, right, just matching the other view, and then it could go down again maybe to 10, something like that. Where so you get the idea that we're animating in the same way, in the same keyframes. So if you did have one sphere inside another, using the Arnold render, you'd get really crazy kinds of interactions that you would never get from that Maya render. So just try seeing what that would look like. And do save, because things do get heavy and can crash. Here the render starting to look quickly quite complicated, and we see all these mutual reflections of one object into the other. Here's another angle at a different point in the animation. You should recall that you should use lights that have some value in exposure. If that exposure is not up to maybe 6 to 12 or something like that, it's going to be too dark in a Arnold rendered scene. You might recall that from the last video. So if you're just creating lights, make sure not just to put the intensity up. This doesn't help that much, it's too strong, but you should go into the light, select it in the outliner, and just make sure it has exposure value that's somewhere higher than 0. You know, you have to experiment with it. Here's mine on 12. Otherwise, it's going to be really dark or even totally black if you don't do that. Won't be enough light to render. Okay, here's another angle or an example, a bit larger render. So you can really see that Arnold's getting into the photons of light bouncing around in here. It looks almost cinematic. And surprise colors emerge as transmission of light is passing through different materials and giving more experimental real-world results. All right, so now you know how to get bumps and transparencies and everything really rendering well in Arnold. Why didn't we start out that way in the first place? Why is the first thing I taught you not the Arnold materials? It's because if you're learning this for the first time and maybe you don't want to continue with Maya, it's still really important as a concept across computer graphics. Also, there will be cases sometimes in a creative future where you can't render with one renderer or another. You have to find a fast and cheap way of doing a cartoony or flat or a different kind of technique looking render, and you have to understand the basics. Versatile and flexible and understanding the foundation of shaders, and if one render is crashing and you know how to implement another, gives you a lot of power and flexibility. So from here on out, I don't recommend that we first build them with the older materials and then translate them, but it's to illustrate these steps of how material is housing color and texture. Hope that makes sense and that there's a method to this madness. Let's just practice it one more time, and from here on out, this is how we're going to add materials and render. We're going to right-click over something we want to give color and texture to. We're going to assign new material, and then go to Arnold, and likely pick this AI standard surface. This opens up, and we're going to right-click Material Attributes. Here, let's get that out of the way. All right, then we're going to click under Color. We're going to put a file texture on this one. Here I found the node under 2D textures. That's going to work. And we had elephant skin for this one. Okay. Then in the attributes, it has the same file texture, which is causing the bump. So recall that that was in geometry. There's a field called bump mapping here. Click the icon, and we're going to put that same file texture of elephant skin on it as well, right there. And that's going to cause a bump. Right away, that bump is much nicer than the other material. Okay, lastly, we're going to material attributes and adding some transparency under transmission tab. Twirl that open, and under weight, click the icon, and I think it had a cloudy pattern. That was simplex noise. And there, we've got an equivalent of what's going on here. We also gave the specular a different color on this, and when we look at the specular of an Arnold material, it's very, by default, very tight and small. We can change that and make that more shiny. Also, there's a blue tint to the color of the specular, I think, over here. Okay, we can do a test render here. This again is render view, which I got under this little eyeball, and just click here to fire off the render using Arnold. So side by side, we're seeing a really beautiful depiction of that bump now here. Again, using the Arnold material and Arnold renderer and Arnold sensitive lights with emissions. All right, so imagine what all this is going to look like when you are using the Maya, you're using the Arnold features with not only your animated colors and textures and materials, but your animated and deforming entity that's shifting and shaping over time. It's going to look really, really crazy and trippy. Here's another angle on this. Let's see how much detail is just wanting to emerge. Okay, let's make the move now to the entity itself. So I'm going to pick up on a couple videos ago of the demo where I'm taking that extruded cube with many quadrants, extruding it. It kind of looks like a sea anemone, and I'm putting deformers on it to twist and turn and pitch it around. And I showed you how to animate those deformers. I'm going to pick where I left off that, and I'm going to start adding some animated textures using Arnold from this point. So let's go there. All right, now in this part, we're going back to that entity that we modeled, extruded, treated, deformed, and these animation, and mainly considering the surface, distortion, deformations. That was primarily what we were concerned about at that time, leading from the first demo video I did for the experimental animation course. Okay, I'm just changing the background by Option B as in boy. Changing, recall that. This is a slightly different one in the first video. It's similar in some ways, so if you're noticing that. Seeing the outline there, I did put a bend, a flare, a twist, deformer on there, and it does have a couple of point lights. So Selecting, hitting 6, you see any textures that are minimally displayed through the graphics card presently. And it's changing some color over time subtly, and the lights are changing, but none of this is rendered yet. None of this is rendered yet. And the material that I set up for it originally was a blend, and then I put on the blend a mountain kind of distorted fractal type pattern. Mountain, gave it some crazy colors. Primarily I stopped there because that lesson was mostly about form and just the surface, getting it moving and distorting and setting keys. Okay, now let's really focus on putting everything we've learned so far and creating an entity, a CG entity to render, to have all those goodies packed in there, and then do an Arnold render and setting this up to upload and turn in your assignment. That would be Project 1 CGI entity. So how to do all that? We're going to give one linear demo accomplishing this so you know exactly what to turn in. I also am going to give you some alternatives that if you hit any road bumps, any obstacles, that you'll be able to turn at least something in its place, even if you don't have the full render finished. I'm going to show you Playblast and other ways to accomplish this. But let's assume everything is a go, everything is working, green lit, and your Maya is not crashing, and you have good access using Arnold Renderer without any problems. Well, first, in the assignment specs, I'm asking you to create at least 20 seconds of looping animation, experimental animation, and we've only here created 100 frames. Not to worry, I'll show you a way to easily loop and repeat frames, so we can get more than 100 frames of animation out of it. So I'm going to plan for 24 frames a second. Your Maya should be set already for that default. If not, they're in the corner is this running man and sprocket here, and then you can select your frame rate. Here's 24 frames a second here in preferences, animation preferences. Also, there's another quick way to change it right here. So that defaults at 24. If yours is not, you can change it, because that will change the apparent speed. That's important to note. All right, so only 100 frames, and I want 20 seconds of animation. So 20 times 24 is 480. So we really need 480 frames here. So put that in, 480. And what we're going to see when we play, it's going to play for the 100 frames and then stop. Okay, so that would be the problem. And then we need it to do the rest of it. There's a couple choices. You could simply keep animating, keep adding more stuff all in between here, and fill out that whole body of timeline with more deforming animation. That is actually the best way to go to get experience. But it does give me the opportunity to show you one other trick, that you could take a piece of 100 frames or whatever length and just continue that cycle and just tweak it within Maya without having to do it in After Effects or something. Why would you want to do this? To give a little bit more subtlety and repeat that loop. So if you have 100 frames, we're going to obviously notice that's more of a cycle when we bring it to After Effects, but we have 20 seconds, 480. We have more opportunities to give it a bit more jazz to make it look like it's continuous after it loops. And it's very important to have still the first frame, 1, to match the last frame, 480. So we'll go through a couple of steps of that, then we're going to go to Arnold, materials, colors, textures, bumps, whatever. We're just going to dazzle it up and then do a final render for delivery, and we'll show you how to set that up. So to begin with that animation looping, how do we get it to keep looping over and over without putting more keys here? If you understand the graph editor, if you've used that before, that is an easy way to do it. And if you've never heard the graph editor before, it's a tool which animators use in Maya. And we don't have to go deep into it, just to show you where it is in Windows Animation Editor's Graph Editor. And it just shows you all the animation keys and graphs, kind of the DNA, or think about it as musical notes of everything that's playing in your animation. But it's only going to show you what is selected. So right here we have that deformer selected, and it's showing that here's the graph. So it's interesting to learn that if you wanted to change its behavior, if we were in this part of the animation at frame 35, we could see by moving it and selecting the key in the graph editor, middle mouse button, move that up and down, we can see how after we create the key we can modify, make more extreme or lessen or tweak the key for that particular deformer. And we're looking at the other deformers here in the outliner. We had bend, say that one. And again, I'm just selecting this orange diamond shape, which is a key, and selecting that left, and the middle mouse button, move up and down. And on this horizontal axis is time, up and down is value, or the amount of movement. And if I hold shift, it constrains it to that place in time where that key is originally put. Anyway, so we can see in that graph editor, if we want to select all the deformer handles at the same time and we move them up and down, it's pretty strong, a little bit strenuous there. So maybe do one at a time. Anyway, this is how you can modify and polish any of the keys, and they're driven by these curves, which give you a very fluid impression of how the animation goes and flows through the timeline. And that's called the graph editor. And these are velocity curves, which represent motion. So there's curves generated for almost anything in Maya that you put keys on. It could be for textures too, but we'll only focus on the deformations for now. If we wanted to cycle this, we can see that after 100 frames, this leader goes into dead space, so there's no animation. So if we wanted to cycle this, we could. Even if we wanted to stretch it out to make it longer, we could just select some of this and even scale it or move it, hitting W, R for scale, W select to move, and then it would stretch out the animation over longer keys, but it would also slow it down, wouldn't it? Because you're asking it to go the same distance and a longer time. All right, let me put that back. So what if we wanted to loop it? Just take this section and have it loop to 20 seconds for 480. How to do that? That is, I want to loop all of the animation on these three deformers from carried on from 100 all the way to the end 480. Okay, the first thing we do is turn on here in View in the graph editor, turn on View and click on Infinity, which will show the line that continues on forever on an animation, which in this case is just a straight line, and straight line equals no movement in the graph editor. So it's just dead. So we roll over it, no movement. That's the normal state. We just turned on the view of infinity so we can actually see it. Well, what we need to do is select, make sure first you have all the ones you want to cycle selected, and then here in the graph editor, select all these keys that compose the first 100 frames or so of the cycle, and then go to Curves, Post Infinity, Cycle. All right, now when we zoom out, it's going to cycle those keys forever. So it doesn't matter how long our animation is here. We could put it at 40,000 frames and it would still cycle it endlessly. You can see if there's a little bump in the edge of one of the cycles, you can select this, the handle, and try to fix it or smooth it out. You can try to change the nature of the tangents that slope in and out of each other by selecting that key. And here's some icons you could experiment with. I won't go much deeper into it because it gets really technical, and it's really made well for doing animation, like character animation. But that's how you cycle. There's this one here, by the way, called break tangents, and if you select a key and hit that one right there, you can separate one side from another side as well. It's up to you. You can see that one coming in is the infinity, so you might select that start, and you could see how it's affecting input-output. Just an FYI, you don't have to use this cycle. You could have filled in unique animation keys for all 480 frames, but this is an opportunity to teach you how to make a cycle in Maya. Of course, you can cycle later in After Effects or other editing media, Premiere, whatever you're going to use, but it's a very convenient way and good to know this way in Maya by using the graph editor. And you get a stab at using this very valuable tool in Maya. So that's it. What's also cool is if I move one key, move it up and down, all the rest of the repeats are moving with it. If I want them to be unique and just change parts differently or asymmetrically of the cycle, I could bake out these animation curves and do unique things to it, which I won't go into now. Just wanted to show you this first thing. All right, so that's how you do the looping. Okay, just looking in the hypergraph, I have some materials that I'd been working with. In the hypergraph, this is my little kitchen of an experimentation here with different types of shaders, colors, textures on materials that I've been just playing with. And they're typical blend Lambert surfaces. A couple of those, you can see how they're reacting. And I made one with Lambert, another one with a Phong surface. And some of these have transparencies on them. And just having fun using the plain old Maya software to render these different tests or exploratory materials. Now some of these have transparencies in them, like the Lambert 1 and the Phong. So I want to try to render this entity with Arnold, and this means I'm going to have to use an Arnold material. So these look pretty cool. I want to push a little further to more interactive lighting and all the things that can come with an Arnold render. So I made these shaders originally with some transparencies in them to give them interest. However, these won't render with Arnold. They look okay using Maya software. But with Arnold, if I try to render it as we saw before, you'll get a much different result. Looks kind of cool because we're getting more realistic looking light bouncing. Not quite enough light there. So this looks really nice in the Arnold renderer, except it's not taking into account the transparencies. And it's kind of harder to see here in the graphics card, but there is transparencies in there. We compare it to the Maya render, we'll see them. So it is supposed to look semi-transparent, more like that. All right, so what we're going to do just to solve this, as we did in the previous examples, is to simply use a new material, and this will be an Arnold material. As before, we're going to use Arnold, a standard surface. So you click Arnold here and you go AI standard surface. And then the Arnold material just kind of looks whitish. We're going to select the material attributes, and as mentioned earlier, we're going to put a color map on the base color. Click here, We will do a leather right here, leather texture, and I'm going to give that a reddish and darker red like that. Okay. And these things we're going to animate over time. And I'm going to go frame 1 and set key on that crease color and also cell size. I want to animate that just for fun. I'm going to do maybe 4 separate keys here. I'm going to change the color a bit, something more expressive in comparison to the previous color. And right click, set key, and I'm going to change the cell size a little bit, set key. I'm going to do one more here, about 3/4 and about 334. I'm going to change the color again. Okay. And change the color on that one. Set key, change the cell size, and the last key will be a duplicate by copying. Just left click frame 1, middle mouse button click the last frame, 480 for this, and then I'm going to just simply set key on everything that I changed. Okay, so those are the changes over time. It's not accurately displayed in the graphics view, but okay, that's one thing I'm going to do. And now I'm going to add a bump to it. Right click, material attributes. For the bump, I'll go to the tab geometry, twirl it open, and the channel bump mapping here. I will put simplex noise for the bump. And it's not displaying it all that well, but that's okay. And for the simplex noise, let's just maybe do a scale animation. So on frame 1, I'll set the key there, and amplitude I'll keep on 1. Frequency, I'll also change that, so I'm going to set key on frequency, and then I'll go about 1/4 in. I'll change it, the scale, set key, change the frequency to be more frequent, like that. Now I'll go 3/4 in to about 350, change the scale again back down. I'll put the frequency back down a bit, like this, and then for the last key, you guessed it, I'm going to copy the first middle mouse button click frame 1, sorry, left mouse button click frame 1, middle mouse button last, then right click set key. And so what's happening, you can see it a little through the graphics, that is animating pattern differences in the bump map only. Okay, and the last feature I'm going to animate will be a transparency map. So go to material attributes. You recall that this is in transmission on the Arnold standard surface, and in weight we're going to click that icon, and here let's put grid, and I'm going to leave it black and white, and we're going to do some repeats. Maybe let's see what 50 looks like. Let's put that maybe back at 30 to start with for the repeat UV. All right, and let's do our first frame. Right click, set key. Let's go 3/4 into about 130-ish, and then let's put that down to 10 and 10. Right click, next key around 340. Let's go back up to maybe 40. And it doesn't have to be symmetrical. We could put different values in each. The keys on those, and for copying the first and last frame, I'm going to set key as well. So we're going to get an animated transparency map, which will get really unpredictable, crazy networks of patterns here. Okay, let's give this a test render. We're using an Arnold material. We should see something. Let's just go and choose the eyeball for open render view. This is the old one. We're going to choose Arnold render and give this a little test by clicking that. And that's what it's looking like. So it's showing the transparencies as these little slits and cuts in here. And it's giving us all the luster and reflectivity that's unique to an Arnold material and renderer. Let's try another angle of it. Let's go maybe over here, see what that looks like. If you want to do a larger render, you could go to test larger in options, test resolution, and go up to 14. Whatever you're set at, you can extend it to a bit smaller or larger. Okay, this is quite beautiful. It's getting this really tiny cellular detailed texture in these transparency slits in here and the bumps. Really looking surprising. It's always going to be different than your graphics view. So test often. And if it's taking too long to render, again, go up to options, test resolution. You can do smaller versions, 10% version, etc. Let's test yet another angle of this. Okay, looking kind of cool, somewhat similar. Try another. Wow, this one is looking pretty neat. This just happenstance pattern all coming together with the lighting and transparency maps. And that's really what experimental is. You find out, okay, I threw that together, but this area looks better. I should aim in that direction more and try to highlight those and emphasize more beautiful or more dramatic or more expressive areas to then slowly evolve your work. Now, just to remind, I'm using the render view and clicking this individual one-to-one. I mean, it's not interactive renderer, and it's the one in here, the render view of the eyeball. There is, and I showed this earlier a couple times, under this Arnold tab, if you're in the modeling menu set, or if you're in the rendering, you'll have this Arnold tab. It's all the same. Here we have an Arnold render view. Now it sometimes crashes. You can see it did on mine. I recommend that when you're doing a lot of heavy textures and stuff like that, that you use this one with the eyeball and do a one-to-one. The interactive is very, very convenient though. It's very fun to do. But when you get a lot of textures in there and you're using a lot of Arnold materials, sometimes it'll fail, run really slow, especially if you're working on a laptop. So my recommendation is stick to just a render view of Arnold one-to-one. That means you just render one scene at a time, and use the Arnold render view, the interactive one, only when you've saved and you test that it's good. And by the way, if my ever does crash and you reopen, it could have saved a crash log and try to save it again. It would pop in this column on the left. Once you reopen Maya after a crash and you click here, it would attempt to find that file and reopen it again, which we got lucky and it did save after that crash. Shouldn't prevent you from saving often. Now, before we set up for a render for this, I wanted to show you one kind of neat thing in the Arnold material. Let's go to material attributes. There's this thing here called subsurface, which is really interesting. Subsurface is when light enters the surface, like if you're putting light right against your skin and it sort of lights up a little pink or red, the blood inside your tissues is actually illuminating, and it's passing through some of the thin membranes. And you could see that sometimes in people's ears when they have a bright light behind them. That internal catching the light and glowing a little bit is called subsurface scattering. And materials in Arnold can do that, can try to simulate that. So if I have a light, I have this light like set right behind this entity and put it pretty loud sitting behind it. And I turn on in the material attributes of here, subsurface, and I turn up the weight and I turn it louder. You'll see that the light really caught inside and starts illuminating behind and inside the materials of this shape. I can also give that light a color, if it were pinkish, light orange. And maybe I'll just turn the weight to really light, 0.05, 0.06, and have this color combination, and just put the light very blasting bright behind it. That could give an interesting back illumination. Now it's suddenly producing this really awesome effect of magma or lava. Seems like pouring out. Very simple tweak, and really it's illuminating the back to get this seeming like it's pouring out or glistening out or oozing out from the center like hot coals or lava or something like that. Material attributes inside subsurface scattering. You can play with the weight and the scale, diffusion, and there's other things we haven't played with. I just want to show you that because it's so easy to tweak and enjoy different test renders to see how they come out. There's sheen, similar to how glistening a coat could be on there. We do have a bit of a shininess to this that's very similar to like a Fong or a Fong E, but you can really customize how that's going to look. Anyway, Arnold's a relatively quick renderer compared to previous technologies, so this may take longer the more you add, but relatively not bad. Just make sure you save. Here's another angle with the subsurface. It's looking pretty cool. All that stuff in there. Those are photons of light penetrating the surface and trying to peek through. Here's yet another angle. It's looking quite enigmatic, like heat is being produced from that backlight. And here's another angle. Okay, we're going to stop about there for all the manipulations and colors and changes in the animation. Now I'm going to show you how to complete this to do the render. This is assuming we've already set up our lights and we have a couple point lights here. You might have another light at the bottom, but we covered that a bit in the last video. So we're going to just go through with it and frame this and set up the render. So for this assignment, Entity 1, we have a 20-second animation asked for. It might be a challenge to be able to render 480 frames of Arnold. That's the ideal. Students had done it before. In a situation where we have less contact and remote teaching, I'm going to be acceptive of a Playblast, or you can do other means instead of a render. I'm going to leave that open to you, and likely you might take that choice. This is to show you how to properly and thoroughly do it if you have the option. So in other words, I'll accept a Playblast for the project CGI entity, but I'm going all the way through with it and show you how to do a render and set that up. And that will be, let's leave it as ideal. Okay, so before I go to setting up the Arnold render, simply doing a Playblast, it's very low stress. All I really need to do is, let's stop the animation. We're going to assume we're all done with this. We got our cycling, everything. And just go to show in this tab, say none, and then show only polygons. Of course, this is not going to give all the luxurious kind of looks with an Arnold render, but at least you would have finished it. Next, you go to Windows, Playblast. Let's go to the option box here. This will open, and for quality, go all the way to 100, and scale, go all the way to 100, and you are going to save to file. Here from encoding, you can do, and keep it on photo JPEG. For format, yours might be slightly different. We're not going to do image, we're going to do AV Foundation, or you might have a QuickTime movie in yours, which is good too. And it's going to click here, save to movie file, browse and put that where you can find it, run on my desktop. Okay, and simply click Playblast. And right now it's running through the timeline and buffering all of these frames. When it gets to the end, it's going to finish this QuickTime movie. I framed it fairly well in the scene. Really don't want it popping out the edges. It's not bad, but if it is popping out, you could do a new Playblast. You can back up a little bit so it stays in the center. There's room around it. Then the movie will pop up as a file, and this is what you can turn in as your entity one. Okay, and this file is saved to your desktop, and you could upload that. Now this shows to me that you've been working on it and if you understand at least the concepts. And it's 20 seconds here. Loopable. Now, if you have the possibility and function to do this, you could do it later. We have the rest of the semester. Try a render, a batch render all the way through. This is a few more steps. It's going to take time, but the results are spectacularly better. Different, of course, because we're using the Arnold renderer for it. For that, the first step really is you want to make sure in a render you're framing this entity as well as possible. So I'm going to go to View. I'm going to the Camera Attribute Editor. This is the perspective view. Scroll down here to the menu Display Options, and you'll have a display resolution and display film gate. Do you see those right there? That's telling you where the edges of the render will be when you render it. Alright, now this size says it's 960 by 540. You want to change that a little bit for your batch render. How do you do that? This sprocket right here, Display Render Settings, choose it. This is going to be important. We're going to, yes, use the Arnold renderer. We're going to give it a name, and we're going to go Entity Arnold and image format. Now if you use a TIFF, you can use an alpha channel in the background to cut that out. Your frames will be larger. If you use a PNG, the same thing. If we use a JPEG, we will have the backgrounds filled with pixels. So if we're going for this, try using image format TIFF, nothing else in the background. We're going to get transparency. So that's really ideal when we go on to After Effects or other media. Scrolling down, we're going to choose a preset, and we're going to choose a square preset because your entity is rather square. So I'm going to choose 1K square. You notice how it changed the borders here, and it's giving you the data 1024 by 1024 square. Alright, so let's close this temporarily. Let's go back, View, Camera Attribute Editor, and let's go back to this setting right here. It's under Display Options, Overscan. Let's put in Overscan 1.5. Okay, now we can finally see the deep edges of everything around it. So now it's very easier to frame what's going to be in the final render and falling in and out of frame. So we know this area is sticking out of frame. We could better position that. And if you want, you could even put keys on the camera by View, select Camera, position it, middle mouse button, hit S, and then find a place that it might be going off screen like this, and position your camera, hit S again on the timeline, and so forth. I'm not going to worry about it too much. Okay, just make sure everything's cyclable. Anything you move or animate, let's ensure it's cyclable. Alright, it's relatively staying in frame. I'm going to go with that. So I'm ready for the final render. We're going to use render sequence, batch render, and render sequence are both contained here and can be used for different groups of multiple frame renders, and that's what we're doing right now. So before we click render sequence right here to render the Arnold sequence of 480 frames, let's go up and double check for the render settings that it's going to take from these settings. So we have Arnold stuff going on here. Let's leave as default, and it does get kind of detailed. The common settings are really what matters. That is where these frames are going to fall. And so what you should make sure is you've named everything right. Let's go through Entity, Arnold. Image format is TIFF. Everything else is okay. Then here, this matters. Make sure it says name.number.extension. This is really important. Otherwise, you can't bring it into After Effects or another program. So it should say name.number.extension. Make sure you do that. Okay, start and end frame, 1 to 480. And do make sure it's rendering from the right place, the perspective camera. Now in render sequence, you can rename some of these as well, just FYI. Everything in here is good. Just make sure you went through name, Arnold, entity Arnold, TIFF, name.number.extension, 1 to 480, perspective camera. You've got the right preset of size, 1K square. Okay, then that's good. Good idea right now would be to save it. And now let's go for a render. So we're ready. We go to render and render sequence. Let's go to that option box. This sequence, again, it's going to take from the settings that are here, so it knows it's going to use the Arnold renderer. And we should set the location. Camera's correct, PRISP, for perspective. Okay, alternate output file location, click it. Make sure that's going into a place that you can find. I made a special folder for this, for my entity frames. All right, when I start the sequence, it's going to render individual pictures, individual frames. So 480 of them, so make sure you have a folder ready for that to drop to in the output location, and then you just click render sequence. All right, so it's going to start rendering every frame in that sequence, and that might take you a while, so you can go and whatever, if you're testing this, you estimate how long it's going to take, then go and get a coffee. But it could also be overnight, knowing how much time it takes to render some of this and how much you put into it per frame. You can calculate that if this is going to be finishable in a short or a long amount of time, and just do a calculation. And this is also why I'm not expecting you to have, during the first time, a completely rendered scene. So if you have 100 frames of it, that would be great. If you even have a couple frames, great. But to make this a manageable project, I wanted to teach you everything that goes in here that would lead you to a fully Arnold result. But for practical purposes, you can just turn in a Playblast. And if that's done well, no worries about it.